sklearn, cluster, affinity propagation, short description, clustering algorithm based on message passing between data points. Inputs, input data, NumPy array or pandas data frame. Rows represent data points, columns represent features. Similarity matrix, matrix representing pairwise similarity between data points. Can be computed from the data using a distance metric or provided directly. Outputs, cluster labels, array indicating the cluster membership for each data point. Cluster centers, set of data points that serve as cluster centers. Fine-tune parameters, damping, controls the influence of old messages during message passing. Values between 0.5 and 1.0. Default is 0.5. Preference, controls the number of exemplars. Larger values result in fewer exemplars. Can be a single value or an array with one value per data point. Default is none, which is equivalent to setting all preferences to the median of the similarity matrix. Convergence iter, maximum number of iterations for message passing. Default is 150. Max iter, maximum number of iterations for the entire algorithm, including affinity matrix update. Default is 200. Affinity, string or callable indicating the similarity metric to use. Default is Euclidean, which computes the negative squared Euclidean distance. Other options include pre-computed for providing a similarity matrix directly. Cosine for cosine similarity, etc. Challenges and fixes. Challenge 1. High computational cost. Affinity propagation can be computationally expensive, especially for large datasets. Related fix. Use a smaller subset of the data for clustering. Consider using a different clustering algorithm if performance is critical. Challenge 2. Sensitivity to the choice of parameters. Parameter values can significantly affect the clustering results. Related fixes. Conduct a grid search or random search for optimal parameter values. Use cross-validation to evaluate different parameter settings. Challenge 3. Difficulty in interpreting cluster labels. The cluster labels assigned by affinity propagation may not be intuitive or meaningful. Related fix. Visualize the clusters using scatter plots or other methods. Analyze the features of each cluster to understand their characteristics.